When we square a number, the result is called a perfect square number. 1, for example, is a perfect square because it is the result of squaring 1. 4 is a perfect square number because it's the result of squaring 2. 9 is a perfect square number because it's the result of squaring 3. And some of the other square numbers that will be handy in this lesson will be 4 squared, 5 squared equals 25, 36, 49, 64, In algebra, when we square a binomial, the result is a trinomial, and we have seen this before. When we square a plus b, for example, we have seen that the result, when we FOIL this, is a trinomial. We even have a formula for it. We even came up with a formula for this. A squared plus 2ab plus b squared. And this trinomial has a special name. It's called a perfect square trinomial. Here are some examples of binomial squares and their expansion. Whether you are using a foiling or using the formula, this is what you get for x plus 1 squared, for example. We get x squared plus 2x plus 1, x plus 2 squared, x squared plus 4x plus 4, x plus 3 squared. We have x squared plus 6x plus 9, x minus 3 squared. I'm sorry, that will be, that should be minus 6x plus 9. Let's have one last. X minus 4 squared is x squared minus 8x plus 16. Perfect square trinomials have some very interesting patterns. One of the striking, one pattern, for example, that is very easy to see is that if you notice, the last terms are all positive. The last terms are all positive, and so it doesn't matter whether you're squaring a sum or a difference, the result will always have a positive last term. And the reason for this is that whether you're using FOIL or using the formula here, the last term, or the last term of the perfect square trinomial is the result of multiplying the second term of the binomial here by itself. So, and whether you're squaring, and whether you are squaring a positive number or a negative number, the result is always positive. So positive 4 squared, for example, is positive 16, and negative 4 squared is also positive 16. Let's look at other properties or patterns in perfect square trinomials. But first, let's write that first observation down. So if x squared plus bx plus c is a perfect square trinomial, then as we have discussed earlier, the last term c is equal, the last term c is always positive. There's another pattern for c that has something to do with b, which is the coefficient of x. Let's have a look at our examples. So our general format here is x squared plus bx plus c. So c is our last term, and b is the coefficient of x, or the coefficient of the middle term. Let's look at our b's. Look at 2 and 1, 4 and 4, 6 and 9, negative 6 and positive 9, negative 8 and 16. If you look at each of those number pairs closely, you will see that the coefficient of x, which is b, if you divide it by 2 and then square the result, the answer is actually c. Like for the first one, 2 divided by 2 is 1, 1 squared is 1. For the second one, 4 divided by 2 is 2, 2 squared is 4. Here, 6 divided by 3 is 3, 3 squared is 9. Here, negative 6 divided by 2, oh, I'm sorry, this second one, this should be 2 here. And this next one is negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. And the last one, negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. So we're going to list that observation down here as, to get c, just divide whatever b is, divide it by 2, and then the result, square it. The last pattern that I would like us to look at has something to do with the middle term bx. If we look at our first example, notice that if we get the square root of x squared, square root of x squared is x, the square root of 1 is 1. Now when you multiply these two, x times 1 is just 1x, and when you double it, you'll actually get the middle term. And this pattern holds true for any perfect square trinomial. Like in the second example, the square root of x squared is x, the square root of 4 is 2. When you multiply these two, x times 2 is 2x, and when you double it, the result is 4x. In the next example, square root of x squared is x, square root of 9 is 3. When you multiply them, x times 3 is 3x, and when you double the result, the answer is 6x. Now let's write that third pattern or observation as our third property of perfect square trinomials. Let's write that as bx is equal to 2 times the square root of x times the square root of c. And these are the properties or the patterns that you will look for if you want to establish, or you want to check if a given trinomial is a perfect square or not. Let me go back here and make a little correction. I need to put a little square here. So let's try to use those properties to solve some simple problems. Over here, if the trinomial given is a perfect square trinomial, find the value of c. So remember that the formula for c is c equals b over 2 squared. So over here our b is 14. So c will be equal to 14 divided by 2, which is 7, and 7 squared is 49. In letter b, our b is negative 18, so negative 18 divided by 2 is 9, negative 9, and when you square negative 9, the answer is positive 81. Next, if the trinomial given is a perfect square trinomial, find the middle term. Our formula for the middle term, bx, is 2 times the square root of x squared times the square root of c. So let's go back here to this first one. The middle term will be 2 times the square root of x squared times the square root of 100. So that will be 2 times x times the square root of 100 is 10. 2x times 10 is 20x. The next one will be 2 times the square root of x squared times the square root of 64. So that would be 2 times x times the square root of 64 is 8. 2 times 8 is 16x. Now let's use what we have learned to come up with sort of a shortcut for factoring a quadratic trinomial if it is a perfect square trinomial. Let's look at the trinomial, the perfect square trinomial x squared plus 6x plus 9, which is the result of squaring the binomial x plus 3. What we see here is that when we multiply x plus 3 times x plus 3, the result is x squared plus 6x plus 9, which means that when we factorize x squared plus 6x plus 9, the factors are x plus 3 and x plus 3. Normally, we factorize a quadratic trinomial by looking for two numbers that equal to the last term when we multiply them, so in this case 9, and equal to the coefficient of the middle term when you add them. In this case, it's positive 3 and positive 3. That's why we have x plus 3 and x plus 3 as the factors. But notice that for perfect square trinomials, there's actually a way that's a little quicker. All you need to do is get the square root of this, and that's that will be the first term of the factor. Get the square root of this, and that would be the second term of the factor. And then whatever is the middle term, the sign of the middle term, that will be your sign here. So let's say we have x squared minus 6x plus 9. That perfect square. We know that the factors will be a binomial square. To get the first term of the binomial inside the brackets, we just get the square root of this, which is x. Then get the square root of 9, which is 3. And then because the middle term is a minus, we separate those two by a minus sign. So let's factorize these perfect square trinomials. Let's start with the first one. So again, we know that the factor will be a binomial square. How do we get the first term of the binomial? We just get the square root of x squared, which is x. The second term of the binomial will be the square root of 16, which is 4. And then because the middle term is a plus, we separate x and 4 by a plus. Using the same procedure, let's do the second one. So again, the factors will be a binomial square. Then we get the square root of x squared, which is x. Square root of 49, which is 7. And then the middle term is plus, so this is a plus between them. Last one. So again, binomial square. Get the square root of x squared. Get the square root of 1. Then because the middle term is a minus, separate them by a minus sign.